Students, I will be your reader for today, so listen up, sit up, and shut up. Once again, I find myself in the rather pungent position of guiding you through the intricate labyrinth of physics at this venerable institution, Cambridge University, where the lecture room smells suspiciously like a sewer. However, I must share some rather grim tidings. Your previous lecturer has unexpectedly departed this life due to an unfortunate encounter with a rogue experiment involving an unstable particle accelerator. So I am delighted to inform you will not be making a comeback. As you may recall, my usual pursuits lie in the realm of Shakespearean performance, where I specialize in pantomime and, dare I say, commercials for luxury cat food. Yet, due to the peculiar mandates of diversity, equity, and inclusion imposed by Job Centre Plus, I am once more compelled to accept any role that comes my way, even if it means meandering through the complexities of theoretical physics at the Cavendish Laboratory. How the mighty have fallen. And you there in the back row. Yes, you, the audacious one. I warned you last time, and I shall not hesitate to repeat myself. Sit down at once, or I'll ensure you find yourself lost in a back alley near the Camden Drag Show, where the locals are less than welcoming, and the morning light reveals far too much about your life choices. Today we shall delve into the enigmatic realm of string theory. Now, I must confess, I have little understanding of what this theory entails or its implications. However, given that none of you gleaned much from my last reading, I have not troubled myself to prepare for this one either. I do possess your previous lecturer's notes, which I shall read from, as I firmly believe an artistic interpretation will serve your education far better than any dry facts. For in life, much like on the stage, what truly matters is a bold spirit and the ability to viciously stab your enemies in the back, metaphorically speaking, of course. Or, as the esteemed Benedict Cumberbatch once quipped to me, didn't I put a restraining order on you before he chased me out of his dressing room with a broomstick? So, dear students, be bold, follow your dreams, and shut the hell up. Now, let me make this perfectly clear. If you dare to interrupt me with questions before I've finished, I will personally ensure you find yourself in a rather uncomfortable situation in the depths of Croydon, wishing you'd kept your mouth shut. And now, without further ado, let us proceed. String theory as interpreted by a Thespian, the encore... String theory, the glittering prima donna of theoretical physics. A framework so ambitious it promises to unify all the forces of nature, yet so elusive that even after decades of study, it seems more likely to win a Tony for most dramatic absence of proof than a Nobel Prize. Ladies and gentlemen, gather close as we unravel this intricate tapestry of vibrating strings, or as I shall occasionally and purposefully confuse, branes. Let us begin at the beginning, or as Shakespeare would say, once more unto the breach, dear friends. String theory suggests that the fundamental particles of the universe are not point-like dots, but rather tiny, vibrating one-dimensional strings. These strings can oscillate in various ways, with each pattern of vibration corresponding to a different particle. Simple, right? Of course, that's until you add the extra dimensions, 10 or 11 of them depending on the mood of the theorist. It's as if the universe were auditioning for Dancing with the Stars and decided it needed an entirely new dance floor. Oh, and branes, not the grey matter in your head, but brains, as in multidimensional membranes. Or is it brains? The similarity in spelling is surely no accident. It seems the universe, much like this lecture, enjoys a good pun. Picture this, our observable universe as a four-dimensional brane floating in a higher-dimensional space. Strings can attach to these branes, or maybe they just get stuck there like chewing gum under a desk. Either way, the metaphor is compelling, if somewhat sticky. But where's the proof? Now, let's address the elephant, or should I say, the invisible string, in the room. In the 50-odd years since string theory was first introduced, not one experiment has confirmed its predictions. Not one. Zero. Zilch. We've built colliders, peered into the heavens, and scoured the quantum realm. And yet, string theory remains entirely untested. If this were a Broadway production, the critics would have closed it in previews. Indeed, String theory's lack of experimental validation is a bit like Benedict Cumberbatch's portrayal of Sherlock Holmes, intriguing, meticulously crafted, and undeniably charismatic, but with an air of detachment that leaves one wondering if it's all just a clever act. Are we genuinely solving the mysteries of the universe, or merely indulging in a cosmic game of what if? Mathematical beauty or theatrical pizzazz? The mathematicians among you will argue that string theory has enriched fields like algebraic geometry and topology. True enough, its mathematical elegance is undeniable. But physics is, at its heart, an experimental science. Without empirical support, string theory risks becoming the Hamlet of physics, endlessly analyzed but ultimately a tragedy of unfulfilled potential. Consider the graviton, a hypothetical quantum particle predicted by string theory to mediate the force of gravity. Despite extensive searches, it remains as elusive as Benedict Cumberbatch's ability to play an everyman convincingly. Let's face it, his Doctor Strange is basically Sherlock in a cape. Branes, dimensions, and dramatic irony. Returning to our brains, those multi-dimensional surfaces where strings can frolic, imagine if one such brain were our entire observable universe. The extra dimensions? Curled up into tiny Calabi-Yau shapes so small we can't detect them. It's a brilliant idea, though one might argue it's akin to Benedict Cumberbatch performing a nuanced monologue in a broom closet. Undoubtedly masterful, but good luck proving it to the audience outside. And speaking of drama, let us not forget the so-called landscape problem. String theory allows for an astronomical number of possible universes, 10^500 to be precise. That's more universes than Benedict Cumberbatch has cheekbones. Critics argue this makes the theory untestable, as it can explain any observed phenomena by cherry-picking the right universe. It's like casting Cumberbatch in every role ever written. Sure, he'll deliver, but is it really the best fit? The final curtain. As we draw this performance to a close, let's confront the brutal truth. After half a century, string theory has produced no verifiable predictions. It remains an intellectual tour de force, rich in mathematical structure and theoretical promise, but devoid of experimental corroboration. Some physicists are calling for a re-evaluation, suggesting that we may need to abandon string theory altogether if it continues to fail the test of empirical science. Yet, much like Benedict Cumberbatch's career, string theory endures. It captivates, it provokes, and it inspires. Perhaps its true value lies not in its potential to unify physics, but in its ability to push the boundaries of human thought. And who knows? Maybe one day, like an actor finally nailing a particularly vexing role, string theory will find its proof. Until then, we remain in the audience, waiting for the curtain to rise on the next act. So, as we conclude this tour de force of academic brilliance, remember two things. First, if you dare to emulate the peculiar arrogance of Benedict Cumberbatch, part-time thesaurus, full-time cheekbone-wielding enigma, you'll find that I am not above sending a strongly worded sonnet to remind you of your errors. Second, should any of you harbour the misguided notion of asking for clarification or, heaven forbid, challenging my artistic authority, know that I am more than willing to orchestrate your enrolment in a Croydon mime workshop. Trust me, no one escapes that unscathed. And now, my dear students, with this cautionary wisdom imparted, I bid you good luck, shut your mouths, and try not to blow up anything or anyone before our next session. Class dismissed!